Okay, I will solve problem number 10, and that is this one that is appearing below. Okay, so now we can proceed with the solution of problem number 10. So, the first step is to arrange the exponents in order from greater to smaller, so we can compare it with that other binomial and see if the substitution method can be applied. So we can see that 3 minus 2 is 1, and 1 minus 0 is 1, so we can proceed with the substitution method. Okay, so now we need to find the u. The u would be the binomial with the greater exponents is inside the parentheses. So the negative x cubed plus 2x would be our u. And our dx would be the du over the differentiation of the u, which is the negative 3x squared plus 2. Now that we have that defined, we can proceed with the algebraic expressions. Okay, so we have that the integration of the 18x squared minus 12, this one stays the same, and times the u. Now we substitute this binomial with the u to the 7th power, times the dx, now the dx is the du over the negative 3x squared plus 2. So then the next step would be to factor out a negative 6 out of here in order to cancel out these two binomials, right? So we end up with something like this, that is a negative 6 times u to the 7 times that du, okay? So then we can find the integration, which is the negative 6 times the u to the 8, because it's 7 plus 1, 8, divided by 8, plus a constant, that is the c. So now we can simplify this expression into this one with factoring out a 2. So we have negative 3 over 4 times the u to the 8 plus c. So the final step would be to have the integration of f of x times dx equals the negative 3 times the negative x cubed plus the 2x of that binomial to the 8th power divided by 4 plus a constant.
To integrate this problem, so we send the denominator as numerator with the exponent as negative, changing the square root. Then we have to check if it's complied the rule by the method of substitution, and checking by it's an x squared, then it has an x, then it's a number, then here is anything. So it's complied. And we have to choose the u because it has the exponent. Then this is the u, then we have to derivate the u, and it's negative 8x, then send it dividing the du as du negative 8x equals to dx. And then Kanati will explain the next steps.
Okay, now that we have our dx, we will substitute in our formula by giving our first value, then changing our u as a variable of u and leaving it with the same exponent. Then, since instead of having the dx, we will substitute it with the equivalent as du over negative 8x as shown here. After that, we will simplify, cancelling the negative 8 by the 16, and it will leave us a negative 2, and the x's cancel themselves. After that, we only need to integrate, since it's already simplified, so you add 1 to the exponent, and it will be negative 1/2, and then flip it and multiply it. It has to be negative since the exponent is also negative. So it's negative 2 times negative 2 equals 4, and then divided by 1, it stays the same. After that, you just pass it to the bottom since it's a negative exponent, and change it to radical. After that, you change the u with the u that you used here, and add the plus c.
And then, as a result, we have this 4 over the u in here, and don't forget to put the plus c.
Well, now we're going to solve problem number 3. This is problem number 3, and in letter A, we're asked to determine the change in the range of the projectile. We have the formula of the range and the angles of the change, which is 10 to 11. In this case, we change the angles from degrees to radians, which we do by multiplying times pi over 180. So 10 degrees is equal to 1 over 18 pi in radians, and 11 degrees is equal to 11 over 180 pi in radians. So to find delta y, which is the change, we just simply use the formula, the function or the equation that we're given, and simply replace both variables. First, we input the second, which is in this case the 11 degrees, which is 11 over 180 pi, and we subtract it to the same, but with the different angle, which is the 1 over 18 pi. After doing all this, we get 6,364.5410 feet over seconds per second. And now in letter B, we're asked to determine the approximate change in the differentials. The formula is dy equals the derivative of the function times dx. In this case, the derivative is equal the initial velocity to the second power divided by 32 is stayed the same because we're said that the initial velocity of 2500 is like constant in both, so that doesn't change. So, and the angle is in this case the x, the thing that changes. So it will be the derivative will be initial velocity squared divided by 32 times 2 times cosine of the angle, and dx is, well, the second variable minus the first, which is 11 over 180 pi minus the 1 over 18 pi, which gives us 1 over 180 pi. So now we input the numbers, the variables, which is the 2500 to the second power divided by 32 times 2 of cosine of 1 over 18 pi, and we multiply all this times the dx, which is 1 over 180 pi, and we get a 6,714.1163. Well, in letter C.
So in problem number 3, letter C, they ask us to interpret the results, and the context of the situation is a projectile, and we are determined to find the change in the range. And the projectile changes the elevation according to the angles, in this case are 10 and 11, and which means the distance will change as the range change, but depending also how much is the difference in both angles, but with the same velocity. And in letter D of problem 3, they ask us under which circumstances is better to calculate the actual change or the approximate, and we thought that it's better to use the actual change because you just input the variables that they give you in the formula and it gives you an exact value, and in the approximate you need to derive first the formula and then input the variables, which are the angle and the first x, so it's better to use the actual change.